And the next contribution is from our department by Yanovych, Daniel Duda, Václav Urba, and Pavel Kosiak. And this contribution is about the structure of turbulence flow behind the NASA 0012 L4. Please, Mr. Yanovych.
Good afternoon, dear ladies and gentlemen. Let me introduce my topic, the structure of turbulence flow behind the NASA 0012 airfoil at high angles of attack and low Reynolds number. Today, we recently investigated structure of turbulent or aerodynamic characteristic for airfoil at low angle of attacks. Actually, until to optimal angle of attack for NASA, for example, for NASA, this is optimal angle of attack consists is 7 degrees. But high angles of attack is also very important task and questions in flow mechanics. Actually, it's very important for aircraft at high altitude and low altitude. In first case, we have different density, and second case, we have low velocity. Not low velocity aircraft move it at low velocity, and for some maneuverability, aircraft must to use high angles of attack. Actually, it was motivation, but main goal this is presentation. It's comparison methodology of measuring. I means actually position measuring probes relative to trailing edge of airfoils. For this task, we used wind tunnel, which was made in University of West Bohemia in the Department of Power System Engineering. Test section, dimensions of the section was 20 by 30 centimeters. This was a cross section, and length of the section was 75 centimeters. For experimental investigation, we used NASA 0012 because it's widely used airfoil for comparison, some investigation with some simulation or some another experimental studies. Hot length of this airfoil was 100 millimeters, and it's the same dimensions was for span and thickness. This is airfoil was approximately B divided by hot 0.18. In this slide, you can show experimental setup. How I said earlier, we tried to comparison two method of measuring, actually position of measuring probe. For first method, we just investigated line cross section, which widely used for investigation structure of turbulence, because of course it's more easily. For second case, we try to save distance between trailing edge and measuring points. It was approximately 0.50 L divided by Horda. Also, for investigation topology of wake, we used 5 pitot tube and intelligent net scanner pressure system. Experiment was made at Reynolds number, which corresponds approximately 20 meters per second, and we change angles with step 15 degree. Accordingly, we investigated structure of turbulence at 0, 50, 30, 45, 60, and 75 degree. Firstly, we try to look how to change wake behind airfoil at different angles of attack. You can see some interesting moments what actually at 50 degree we can clearly observe vortex tip, and then if we increase degree we cannot to see, because think of the wake greeters when size of vortexes. When we try to find where is our measuring point, which was located behind trailing edge, actually behind it trailing edge, how its points placed relative to the wake, and we can clearly see what this is a point not outside the wake, it's present actually in the wake. Now, when we make experimental investigation by hot wire, we used probe 55P15, and we get some distribution of normalized velocity and standard deviation depending on the angle. We can to observe it's some similar distribution, but if to look more precisely, we can to detect what at constant distance we have lower dimensions of the wake. Very interesting results. When we change angles of attack and measuring distribution of velocity, we can detect some groping. Until 15 degree, we have maximum value of velocity, and after that we have minimum. After that, we try to analyze spectrum and power spectrum and dissipation spectrum of stream-wise fluctuation, which also show some groping between angle of attack. How I said earlier, optimum angle of attack is approximately 7 degree. It's clearly can to observe from report from Sandia National Laboratories, whereas we can to see this is value 7 degree for optimum relation lift and drag coefficient. Also take your attention for this is moment what lift coefficient maximum observed at 45 degree. After that, we try to calculate the structure of we try to analyze structure of turbulence depending on the angle of attack and depending on the measuring methodology. We can see clearly what distribution of standard deviation, also Taylor scale and integral length scale of vortexes sharply have big difference actually at 45 degree, which corresponds maximum lift coefficient. Another parameters is means energy of dissipation and integral time scale almost similar. It means what conclusion? It means what when we want to investigate it structure of turbulent at high angles of attack, we must to think which methodology we want to use, constant cross-section or constant distance, because after 45 degree its value of structure of turbulence have a big difference. In future, we plan to more concentrated steps of our measuring and investigated approximately at 2 degree angle of attack, and to observe which structure of turbulence depended on methodology of measuring at optimal angles of attack and different distance. Of course, acknowledgement, this work was supported by the Project of Technology Agency of the Czech Republic, Program Epsilon, and the Project IDEC. Thank you very much for your attention.
And please again question or comments to this experimental contribution.
Andreas Weiß, Technical University Yanovych in Germany. Do you know that flow is still attached at 15 degrees angle of attack? Or second question, or alternatively, have you already also measured angles of attack below 15 degree angle of attack, maybe as a reference? Yeah, I wondered that you started with 15 degree. You know, it's more or less probably flow is already separated, or maybe close before separation. And therefore, I would always choose at least 5 and 10 degrees additionally to have a reference with surely attached flow here.
Thank you very much for your question. Actually, we choose step 15 degree and try to measure in with increasing angle of attack for comparison methodology of measuring.
Okay.
Because usually many papers in many papers scientists measuring just in one cross section and not to save distance, even to change angle of attack at a high angle attack. This is work was made for comparison results
Of different methods.
Yes.
And you were not so interested in the behavior or in the real physics of the airflow.
It will be in future. We continue.
No, I understand.
Yeah.
Thank you very much.
Please next question or comments to this contribution. No. Thank you again, Vitalii.
Thank you very much.
Again.